Hello, good morning, good afternoon, and good evening. Welcome to No Food Live. I'm your host, Courtney Riggle, joined by my co host, Matthew Lang. Welcome to Season 2, Episode 3 of the No Food series. Our topic today is KnowFOOD-AI, artificial intelligence cyber infrastructure for food and food systems. For those of you who are new to our series, No Food is here to dive deep into the world of food informatics and the Internet of Food. We interview scientists, thought leaders, and innovators to foster collaboration and advance global food system digitization and democratization efforts. No Food Live airs the third Thursday every month, but you don't have to remember that. You'll never miss an episode if you click down below and subscribe to our YouTube channel.
Hi, everyone. We're so pleased to have you join us on No Food Live today, or whatever day you may end up watching this, since our previous episodes are all available for streaming in case you missed the live broadcast. We thank you so much for tuning in, and your feedback continues to make our episodes better. If you have ideas for new episodes or guests, we want to hear from you. So you can email us at knowfood, that's K-N-O-W food, at ic-foods.org, or you can just click the link in the video description down below.
Platforms and cyber infrastructures for food and food systems that are poised to help farmers and other decision makers manage information in order to improve efficiency and resiliency in agricultural production systems. Today, we expand our focus to look at artificial intelligence, or AI, and how new efforts to expand the scope and accessibility of AI technologies throughout the food system can be a powerful step towards sustainability.
We open our conversation today with Dr. D.K. Panda, a computer science professor from Ohio State University and lead principal investigator, or PI, for the ICICLE Institute. He will introduce the Institute and explain its core goals and value propositions for the food system in general.
Second up today, we're pleased to welcome Dr. Patrick Huber, a research scientist in the Food Systems Lab at UC Davis and lead for the Smart Foodsheds use case in ICICLE. Dr. Huber is an expert in spatial analytics and develops tools and methods to support land use decision making.
And rounding out our group today is Dr. Beth Plaley, the executive director of the Pervasive Technology Institute and founder and director of the Data to Insight Center, and the Michael A. and Lori Burns McRobbie Bicentennial Professor of Computer Engineering, all at Indiana University, Bloomington. Professor Plaley is an expert in AI research infrastructure, AI accountability, and open science and reproducibility, with a core focus on making data from research available for broader use. Welcome, Beth.
So let's get started. First up, as we mentioned, we welcome Dr. D.K. Panda, professor and distinguished scholar of computer science at The Ohio State University. And he's noted by his colleagues as being the world's leader in high performance computing, HPC, and developing intelligent adaptive HPC. As mentioned, Professor Panda is the lead for the new NSF funded Intelligent Cyber Infrastructure with Computational Learning in the Environment Institute, which is ICICLE, so we can actually say that. But ICICLE is a great name. I'm glad you came up with that. Anyway, we'll be discussing that today. Professor Panda, DK, it's such a pleasure to have you on No Food today. Can you introduce us to ICICLE and share your vision for how AI can be used as a tool to improve food systems and food system resilience? And quickly, before you start, let me remind our live audience that you can type your questions into the YouTube comments at any point during the show, and we'll see and respond to them live. So welcome, DK.
Okay. Thank you, Courtney, and thank you, Matthew, for inviting me to share some of the things what we are doing in this ICICLE project. So I think I should be able to open my slides and continue. Okay. So as you can see, so this is an NSF-funded AI institute. We just got awarded this year. The title indicates intelligent cyber infrastructure with computational learning in the environment, the ICICLE. So we have a very short video to introduce this institute. So let me first play, and then I'll try to give you more details as we go on. I think there seems to be some problem with the sound, I believe. We are playing. I thought we tested this, am I right? Do I need to do anything? Sorry for the interruption. Let me share the slides again. Just to give me 1 minute.
Hi, DK. I'm wondering,
Yeah.
do you have speakers on your computer?
No, it is. Not. I have not connected to anything else.
I'm saying if you is the sound coming into your headphones?
Yeah, I am able to play. I am able to listen.
Okay, maybe just unplug your headphones and then the sound will come through the speakers and we will hear that way. Oh, but I think you have to switch the input from your mics. Sorry about this, folks.
Can you see the screen now?
Yes.
Okay.
Screen.
So let me then move to the next slide, and then we'll see whether the audio comes clearly or not. Okay.
A policymaker wants to know how land use policies will affect a region's biodiversity. A farmer is concerned about how new weather patterns will affect crop yield, while food distributors and public health officials are concerned with how supply chain disruptions will affect deliveries of nutritious foods to communities. Current technology can provide data and models to tackle grand challenges such as biodiversity, conservation, and agricultural and food system resilience. But it still lacks the infrastructure to link across data and models seamlessly to answer complex questions from diverse stakeholders' perspectives. Even AI experts are challenged to create standardized solutions across domains because a standardized cyber infrastructure integration with AI just doesn't exist. Enter ICICLE, intelligent cyber infrastructure with computational learning in the environment. ICICLE is an institute dedicated to building a national AI-driven computational infrastructure that functions as a utility, much like our electricity, water, and transportation infrastructure. This new utility will enable the delivery of AI to end users with the flick of a switch, enlightening solutions for imminent problems of national, regional, and local importance. ICICLE will provide an operational rationale and framework for a cyber infrastructure that delivers wide and easy access to smart computing, plus a conversational interface that allows stakeholders from diverse domains to ask questions and receive answers informed by currently available data and knowledge. For example, food distributors, emergency food agency managers, and logistics company executives might ask, which food supply chains will likely be affected by an approaching storm? The ICICLE conversation agent might respond with, I will predict future states of your regional supply chain under forecasted weather scenarios and evaluate alternative scenarios. Okay? Upon confirmation, ICICLE would then retrieve satellite data on weather, connect to weather forecast models, acquire inventory data for food producers, processors, distributors, transportation networks, wholesalers, and retailers throughout the region. Use AI models to forecast supply chain conditions from a baseline and alternative logistics that maintain consistent food supply for vulnerable populations, and estimate supply chain disruptions based on historical and current data from other locations, mindful of privacy. ICICLE will go even further by accessing high-performance computing centers to backcast and learn how reconfigured landscape-scale precision agricultural production and distribution systems could integrate with alternative supply chain infrastructure to avoid similar future disruptions. Using an orchestra of smart cyber-infrastructure elements, ICICLE produces a symphonic answer that improves outcomes for diverse stakeholders. ICICLE holds the potential to transform today's AI landscape from a series of fragmented tools for use by a few to one where democratized AI and integrated plug-and-play architecture empower diverse end users with knowledge and data flows that are science-based, traceable, transparent, reusable, and trustworthy. Introducing AI for CI for AI. AI for everyone.
Thank you for listening to the short introduction. So as you can see, so this ICICLE, we are trying to have a national infrastructure that actually try to enable AI at the flick of a switch. The broad objective is to achieve integrated plug and play AI. Inside that, there are a lot of internal components. We'll be trying to go over those things in more detail. But the broad goal is to have really democratize AI and to address societal problems, national priorities, and also grow the new generation of workforce. So the overall institute consists of multiple thrusts. So these are the technical thrusts, the CI for plug and play AI, intelligent CI, and the fields ACE to HPC cloud. And we also have a big focus on the broadening participation in computing, workforce development, and we have selected 3 use-inspired science cases to validate our propositions. One of them is smart foodshed. We'll talk more about that later today. But we also have another 2 use-inspired science cases, animal ecology and digital agriculture. And of course, we have focus on education and outreach, and also collaboration and knowledge transfer. So there are a lot of institutes are participating here. There are 14 institutes, as you can see, starting from the East Coast to the West Coast, starting with RPI, University of Delaware, Ohio State University, Ohio Supercomputer Center, Case Western Research University, Indiana University, University of Wisconsin, Iowa State, TAC, SDSC, UC San Diego, Utah, and of course IC Foods, and also UC Davis. Besides these primary organizations, we also have a lot of collaborators, as you can see, spanning multiple government agency, national labs, research institutes, NSFAI institutes, hospitals, universities, industry, and also some international collaboration. So this provides a very high-level overview of the ICICLE leadership team, the PIs and co-PIs. But inside that, we have a lot of these components. I'll talk some of these, like a foundation systems AI, intelligent cyber infrastructure, and then of course we have the team leads for various other thrust. So the broad rationale is as follows. As you saw from the video, if a store manager is trying to ask a question, how should the supply chain be handled with an upcoming storm? Similar examples also hold good for, like, say, digital agriculture. A farmer might be standing in the field and trying to take a decision: should we harvest the crop today or not? So in these kind of scenarios, you will see that the data actually comes from the so if you see the other slides moving. Okay. So as you can see, the data is being generated on the sensor, and then we need to take the data through various stages of computing. And this is what the vision of the ICICLE to design the cyber infrastructure, so that in a very with a least overhead, we can actually achieve this in a plug and play manner. And over a period of, like, let's say 2030 or something like this, people should be able to utilize these different components as they need to design this entire ecosystem.
So if you go down a little bit more details, you will see there are a lot of challenges, especially with respect to heterogeneity. We have heterogeneity in computation, context, data, model, interface, etc. So one of the broad goal is to actually design and standardize a lot of abstraction layers. So this is where like we have intelligent CI, adaptive AI, federated learning, knowledge graphs, model commons, and also conversational AI. So these are the components of the main research our team will be carrying out. We have on the right side co-design for the use inspired science. You will hear more from Patrick on the smart food set. But inside this, we have the foundational systems AI component we need to design, and then the intelligent cyber infrastructure. We'll have CI for AI, AI for CI for AI. I'll introduce that very shortly. The overall software, and then visual analytics, and of course, a lot of privacy, accountability, and data integrity issues, which Beth will be focusing on. So if you take a look at like to design this kind of a systems from really end to end, we need a lot of foundational systems AI. So we call it like these are the components or the modules or the softwares we need to design to really make this entire things work. And within that, we have knowledge graphs, model commons, adaptive AI, federated learning, and also conversational AI. And then we have CI for AI. That means how the cyber infrastructure needs to be designed so that the next generation or the upper level applications or the user science cases can actually take advantage of the AI. So here we have high performance deep learning, high performance data management, edge intelligence, AI adaptive, edge wireless, and also control and coordination. So the new thing what also we are trying to propose is called AI for CI. Okay, so that means we call it like today's AI is tomorrow's CI. So that means we want to actually design some things which will be really utilized in the next generation hardware. So for example, here if we just take a look at only the middleware component, here you will see that let's say we want to do some high performance deep learning. There are so many different kinds of systems out there. Can we make something like an intelligent primitive which will learn from the hardware? So when a actual application is running, it will be able to find out where to run and what mode it will run so as to satisfy the requirements from the upper layer. And we'll be putting together all these things in the software. So this is the research plan, the complete ICICLE software architecture. We'll be leveraging the software which is being designed at Texas Advanced Computing Center called TAPIS, and that already is available. And we'll be trying to build on top of that to introduce all these other components. So with this, I just want to indicate that ICICLE will enable a global leadership here. So the broad idea is to integrate into the national CI ecosystem. We want to make sure it is integrative and interoperable, leverages existing recognized capabilities, collaborative, and also sustainable. So in this context, we are always looking for opportunities to get engaged with the community. So this is like the podcast is also one of the activities here. So we are very open to interact with all the interested parties, whether you are researchers or faculty or students or from industry. So we'll be very happy to work with you. So with this, I'll stop here and we can move to Patrick, and we can always have a discussion and over the chats. Thank you.
Thank you so much. Okay, that was fantastic. Really a great overview. And before I continue on with our next speaker, I did want to disclose a little further something you mentioned, and I should have said it at the top of the show, that IC Foods is part of ICICLE, and just a little journalistic integrity here, and that I am part of the leadership team with ICICLE. So it's not completely objective reporting happening here as part of this, but nonetheless, I think that this is really, really important for people in the food community to know, and to know about this effort. So my question for you is, if you can, in 1 minute, so we can move on to the next speaker. But there's a lot of moving parts here. It's a very complex institute. I'm wondering how, what what do you focus on first? How do you get something this enormous with this many moving parts off the ground? What's your strategy for that?
I mean, we have a large team, Matthew. As you know, you have been involved also in this thing. We have developed these concepts almost now 1 year since the day we started, and we are still learning from each other. So there are so many challenges, but the way we are trying to approach is like we'll go step by step. This is like a 5 years grant, but we would like to see what we can do in the near term. But at the same time, we want to focus on the framework. We want to focus on the standardization. We want to focus on the foundations so that we can build on top of each other's work. And might be by the end of first year, we'll definitely have some of the components ready, initial components. We'll be able to showcase some of these use inspired science cases. And then from there, we'll try to get more momentum and then keep on building.
Great, thank you. And just a little inside baseball for our viewers. It's really been something spectacular to work with this group, with so many people coming from so many different positions. And like DK said, we've been working together for over a year because we wrote the proposals together. And even though we're only a month and a half into actual funding, we've been working together for significantly longer. And I just wanted to make that clarification for folks. Thank you so much, DK.
Thank you.
Now let's shift to our next guest, Dr. Patrick Huber. Patrick leads the Smart Foodsheds use case within ICICLE. Dr. Huber is a geographer who is an expert in spatial analytics and developing tools and methods to support specifically land use decision making, but I think expanding into all kinds of decision making and scenario development. Welcome, Patrick. Thank you so much for joining us today. And real quick, before you begin your slides, I wonder if you can just take a moment to bring our audience along. And just tell us, for maybe the non-food people who are in the audience and who are AI folks, what's a food shed, and what does it mean to be smart?
Thanks, Matthew, and thanks for that intro talk, DK. So the food shed is a regional scale area where food is produced, consumed, and interacts with all of the natural, social, financial systems that are involved in that food production and processing and ultimately consumption. So it's everything that's happening in a region that food is somehow involved with. Am I ready to start here, Matthew?
You are. We just need you to put your slides into presentation view. Thank you so much for that.
Yep. Okay. DK touched on a number of the things that I'm going to be talking about over the next few minutes, but I'm going to do a little bit deeper dive.
Patrick, yep. We're looking at your design view instead of the actual slideshow view.
I'm not sure how to change that. It's in the slideshow view for myself.
I think maybe to save time right now, you could just zoom in on the slide. Is it possible to shrink down just look at the design view then, since that's the one we're seeing, without looking at the other view, and shrink the sorting side down and zoom in on the other side as much as possible? Yeah, I think that's going to work fine, just like that.
Okay. Sorry about that. I'm not sure what the issue is here.
Thanks.
So moving from that brief description of a food shed and the food systems, there's a number of challenges that are inherent in that. And just from the description that I gave, there's a lot of people with a lot of different interests, a lot of actors within a food system, within a food shed. There's all sorts of types of data, whether quantitative, qualitative. They're most often not linked together. They're siloed, maybe difficult to find. There's many different kinds of systems that we're looking at, whether it's natural systems, social systems, many financial systems, physical infrastructure, and these are all linked together. And so understanding the food system requires understanding those linkages. Oftentimes, decision-making within that context involves trade-offs. So a lot of the challenges involve better understanding of what those trade-offs are so that we're making decisions in a much more transparent way. And there's ultimately unequal access to technology and information. There's many actors that don't have access to data sets, don't have access to technology for doing different kinds of analyses and understanding the food systems. So moving into a smart food shed, smart food sheds have a lot of the information linked together in ways that are operable to be able to move from one kind of data to another to help answer complex questions. Similarly, there's, as I said, many kinds of stakeholders, and so linking them together, being able to communicate and interact in more effective ways leads to a smarter food shed. So one of the major approaches that our smart food sheds team is taking is trying to understand the interplay, the interactions between these actors using ontologies and knowledge graphs. This is a way of formalizing the relationships to allow querying across different kinds of information and just understanding the system better overall. So this is just an example here showing some visualizations, which is going to be one of our focus areas over the coming year. So we can see over on the left side of this slide in the blue circle is Morris Grass-Fed, which is a company that produces meat. And they are linked to different people, different sustainability issues and themes. And so if we look over to the right, one of the sustainability issues that they're involved with is grasslands, impacts on grasslands and the ways that grasslands impact their business. So if we move over the link to that bubble on the right, you can see all of a sudden that there's all sorts of other organizations that are dealing with grasslands. There may be different kinds of funding programs associated with it, regulations. And so we can start moving through all of these linked pieces of information using knowledge graphs. Another direction that not just our team, but the whole ICICLE Institute is taking is involving natural language processing. What this does is allows non-experts to actually interact with the information, with the tools. So a user could type in on a website, where should we expect food access issues because of supply chain disruptions due to the current wildfire, and who can help address the access issues. So being in California, wildfire is a huge concern. All sorts of land use questions come into play, and that can affect food access. So you don't need to know the models, the tools, the data sets necessarily, but using natural language processing tools, we can have the AI tools in the background, linking these things together and coming up with an output that is usable to non-experts. Further, as we move through the 5-year lifespan of this first round of ICICLE, we want to develop some automated use case workflows. So we can use the natural language processing to come up with a scientific and analytic workflow, as well as a stakeholder process workflow that are linked together and can point you to data, to models, to stakeholders that should be involved in a particular use case, all to lead to a more informed outcome for planning within the smart food shed. So these are just a few of the things that we're going to be focusing on. And over the next 5 years, I'm sure there's a lot more that we haven't even considered yet. But I will leave it at this for now and turn the presentation over to Beth.
Wow, thank you, Patrick. I can see so many different directions that this can be useful. Just from your experience with this information and these decision trees and just the challenges in pulling this information together so far, how do you see, just kind of in the early levels, that making a food shed smarter will influence or improve production and processing, or how a food system functions? What do you think the low-hanging fruit are?
I think one of the things that we can do immediately is have public access to the knowledge graphs that we're developing to understand who partners might be in coming up with new food production systems, for understanding who some customers might be, and for understanding some of the vulnerabilities and impacts that their businesses might face.
Great. Thanks, Patrick. So let's shift now and turn to our final guest for today, Professor Beth Plaley. Dr. Plaley is the Executive Director of Pervasive Technology Institute, founder and director of the Data to Insight Center, and Michael A. and Lori Burns McRobbie Bicentennial Professor of Computer Engineering, all at Indiana University Bloomington, or IU. Professor Plaley is an expert in AI research infrastructure, AI accountability, open science, and reproducibility, and has an interest in making data with research available for broader use. So really that democratization piece. Professor Plaley, thank you so much for being here. And we noticed the tagline for the new ICICLE Institute, and we've mentioned it a few times, is democratizing AI. Can you tell us more about the areas you lead within ICICLE and what it means to democratize AI?
Excellent. Thank you so much. It's first of all, it's a delight to be here. And let me come back to the question of democratizing. I will make a few remarks, and I think then addressing that question in the context of these remarks, I think may be helpful. So what I want to do is cast more broadly than ICICLE, and then narrow into a dimension of ICICLE, because one impacts the other. So if we look broadly, and many of you I expect are familiar, some of you I expect are not. There's a national effort it's a federal recognition that artificial intelligence, when responsibly deployed, and that's a qualifier, when responsibly deployed, can have great potential to improve our society and our economy. So this recognition is flowing to our federal agencies, and they then are taking action to fund projects such as ICICLE. So the funding of ICICLE is coming from the recognition that AI, responsibly deployed, can have great potential in society as a whole, and for our project in the setting of food scarcity, food systems, and supply chains and whatnot. So that's one point. Another point is the National Science Foundation funds distributed national cyber infrastructure, big computers, fast networks that are spread throughout the United States. And the purpose of this is to facilitate science and science research and educational use across the country. So that's the second point to keep in mind, because the ICICLE project has a cyber infrastructure component. And then finally, the National Science Foundation, which again is funding ICICLE, prioritizes developing capacity around new areas such as artificial intelligence. And it does this by passing down the requirement to awards such as ICICLE that we are committed to not only advancing research, advancing economic use and societal use, but also taking recognizing the value of ourselves and our ability to understand our technologies, understand the AI, work with them productively. So that is a core part of ICICLE as well. So looking at the ICICLE project, one could say it is artificial intelligence plus national cyber infrastructure and the targeting of both the developing of the workforce and then taking the research that is done and pushing it both for scientific research and for the use by organizations that may want to adopt and use the technologies. So the contributing to the national cyber infrastructure is a form of knowledge transfer, as is pushing products into the hands of organizations and even individuals that may use it both in their research and in their day-to-day work. So this means that the project will strengthen food and food systems research, will strengthen organizational and institutional capacity to leverage AI developments, and will strengthen both the individuals and the community's capacity to understand and apply developments from ICICLE. In other words, AI responsibly deployed into food and food systems research will enhance individuals, will enhance organizations, enhance communities. So it's a broad mandate, and I think a very important mandate. So looking at each of both the knowledge transfer and the workforce development, we envision that this is a 5-year effort. We envision focusing initially on the ICICLE team. So, assuming or expecting everybody has the right set of skills, including things like bias. AI has bias. That's a very important consideration, particularly when data involving humans is involved. So just as AI has bias, because data sets have bias, humans have bias, unconscious bias. So, bringing awareness in these kinds of issues and transparency and integrity issues to the team, and then branching out a bit further and looking at the immediate stakeholders and partners, and these may be organizations that are committed to, say, trying out new technologies. So what how do we serve them as a community, and then the wider community, and this is looking both earlier in time in terms of our up and coming food and food security people in K through 12, and then also looking beyond the project to professionals who are actively working in the field. So what you see across the bottom, which I won't go through every one of them, are some of the programmatic activities of workforce development that target these specific communities, such as, for the stakeholder partners, there's an educational fellows program, which is a way by which people, students and faculty, can engage with ICICLE and contribute to ICICLE in ways that benefit them in their career. And I'll come back to another piece of this here. And I will point out, yes, I'll come back to a couple pieces here. So what is the benefit to engaging with an NSF-funded project such as ICICLE, and ICICLE specifically in this case? So the tools that emerge from this project will be available to community members to try out and provide feedback on. These we put out there for use. We want to see things used, and we welcome feedback on those. We are also discussing developing tools and software that can be used by organizational partners. Our PI DK Panda is well respected in maintaining software that can be used by communities through decades of time. So bringing that same commitment here, where tools are made available to organizational partners. And then there's something like a service model that allows the ICICLE project to support these tools over the long term. So there's an expectation of longevity in what we're doing here. Students and community members will have opportunities to engage in the research, and this we're envisioning through something called a community-based participatory research model, where the community members work alongside of researchers on problems. which I think is a super exciting model and a successful model for community engagement and also for research outcomes that have the benefit of actual community input to them. They tend to be more powerful. We will work with K through 12 teachers to design educational projects that they can use in the classroom. And then also, and this was a reference I made in the earlier slide, we intend to work with the professional societies that are in the food and food systems area to and other areas of relevance, animal ecology and whatnot, that reflect AI into their professional certifications. There are not many projects of the scale of ICICLE that are actually trying to integrate AI into, kind of into the discipline in as significant a way as this project is funded to do. So we can, through inspired by the tools we develop, we can provide means by which people learn about AI embedded in the context of their work in ways that other projects that don't combine AI and food systems so closely cannot do. So that's the working with the professional societies. And then just to finish up, how does one engage? So again, so the project reminder, the project is AI plus national cyber infrastructure. And what does that yield? That yields impact for science research. We're clearly serving researchers in this area. I think Patrick gave an excellent example of some of these needs. And then we're also serving the food and food systems both workforce and, I'm sorry, there should be commas here, workforce and industry and organizations. So it's a broader mandate. So again, with respect to how one engages, we have a website that's developing rapidly. So please, if you've checked it, please check back as it develops. We will be developing a social media presence that will be targeted toward community engagement opportunities. We anticipate we will define partner opportunities and make those available for organizations. And then in the meantime, while we're getting set up, please reach out to any of the three of us with any interest that you have and any questions that you have. So with that as a final comment, coming back to what democratization is. And I think here, we often see this in research where some of the tools that we are using are we require a fairly high skill level in order to use. We've had disciplines, particularly astronomy, where by making efforts to lower the barriers to access, we've had engagement even in questions of research by a broader set of the community, and this is sometimes called citizen science. But I think, so that's one form of democratization is, can we lower the barriers to the tools that we use every day in research? Can we lower them so that they can be used by people that don't have the technical background and skills that we might have? And I think also, democratization is perhaps I would hope is also an educational concept that that allows AI to be seen as something one can use with a broader context around which it can be used for good, and what the problems might be in thinking it's used for good when it might not be. So I'm hoping that AI as a whole becomes a positive force in the classroom and in use more broadly in organizations and industry. So I will stop there. Again, thank you for the invite.
Wow, so great. And I can't take this smile off my face right now because I'm just so happy to actually be on this project and be part of this team. So just thrilled. Maybe what would you say to the members of our audience who are in private industry and say, well, we're democratizing AI because we're making AI products, platforms, and we're bringing AI to the people, and maybe we don't need something like this. What would your response to someone like that?
And there are, I'm sure, tools that are useful that profit-oriented companies are putting out there, and this is not to speak to nonprofit organizations which are driven by something different, but a company that is driven by profits uses profit as their primary objective. And that will be had through whatever means. And so I do think the goal, I think the goal of a federal agency, and I did spend, as many of you know, I spent 3 years at the National Science Foundation, so I'm somewhat biased, but the goal of these federal agencies is not that. They're not profit driven. They are driven by advancing, the society and the economy of the United States. And so what a project like ICICLE has is that public responsibility to democratize AI in ways that are not profit driven. And so that I think is the primary benefit of utilizing tools. That said, we do intend to, we seek to work with companies that are wanting to, we consider ourselves as much researchers as leading the way. We're multiple years ahead. So we do want to flow some of our solutions into industry, but not precluding its use in an open forum. So we're looking at models of engagement that allow us to support these industry users, again, without cutting off the access for broader research and education purposes, which is our mission.
Great, thank you. Why don't we bring the rest of the crew back on the screen here? And I'd like to actually open this question up, maybe starting with you, Patrick, sort of bouncing off of Beth's response. If you were to look at the landscape of AI in food systems, and sort of project out what we might, the things we might be able to do in food that we can't do now in food systems, when the data sets are connected and the food sheds are smart. What do you see, Patrick?
I think that I see just much greater transparency in decision-making processes. I see the trade-offs in those decisions to be much clearer. I also see a lot more real-time data that will be able to be brought into decision-making, and to look at all just a wide range of both impacts from the food system on other systems and the vulnerabilities in ways that we can't right now with things relatively siloed.
I think that's great. So one of the things that comes to mind is resiliency of the food system, and it seems like we experienced some pain points in food system resiliency with COVID and the food system in particular. Do you see AI systems being able to help with that kind of problem, Patrick? I just want to stick with you for a second on this.
Yeah, absolutely. COVID really helped reveal some of the underlying weaknesses in the current food systems, and I think is really motivating us to address some of these. But yes, I see there, if we build something like ICICLE out to its fullest potential, that will be able to have much greater efficiency and effectiveness in addressing things like immediate food access issues and other kinds of issues like that. Yeah.
Great, thanks. And DK, you mentioned there's a couple other use cases that are related to food as well. The smart agriculture, digital agriculture, and even the animal ecology, which is on the edge of that. Can you talk a little bit about how you see maybe these use cases coming together in the broader ICICLE picture? What that might look like?
Yes. So Matthew, so we selected these three different use-inspired science cases. So you can consider them as like three verticals, but they are not actually very distinct. There are a lot of commonalities. Okay, so that's how we actually chose, so that these three have some commonalities, but at the same time they have some differences. So that actually will allow us to design the system so that which will be versatile, and then we can keep on adding more verticals as we go along. So if we go down, like I gave an example of like a digital agriculture, there are a lot of problems there, like where the real data you need at your fingertip to take the decision. Like I mentioned about like harvesting a crop, or think of like a pesticide, like a spreading pesticides on the farm. Like these days, if you see, I mean, you might have a very big farm, but could be some part of the farm has some kinds of diseases. Okay. Now, currently, what happens without those kind of a knowledge, many times the farmers just go and spread pesticides all over the field. But the question is, like, can we really, let's say, take an example of like flying a drone and then get an image, and then on real time we need to find out, saying, okay, this area of the farm will be requiring this kind of pesticides, or this has this disease, and the other part will have a different kind of disease or different kind of pesticides to spread. So in that way, actually, we'll be doing a lot of, not only will be helping the farmers to really have a good utilization of the pesticides, but it will also help the environment, because we just don't want a lot of unnecessary pesticides to be put at all places. So same thing in the harvest. So these are all our like on the roadmap kind of things. A lot of examples are very similar. Once we build the initial cyber infrastructure, we should be able to provide extensions for all these different use cases.
Courtney,
Thank you. I think we have a really great question coming in from our YouTube audience. Let me put it up here. And this could actually go to anyone here. But there's an argument here that the Mayel says, one could argue that there's way too much food in the food system and half is going to waste. Can your project help address this issue? Maybe working with charities, NGOs, etc. So bringing the food waste question into the conversation. Are you having those conversations with ICICLE, or how do you envision addressing that kind of a topic?
As of now, I mean, this falls into a larger umbrella. We have not exactly identified like who will be working on these at this point, but this is a very big issue. And I think we also know, I mean, many cities, they already have some kind of organizations going there. They have a network which tries to take like a food which going to be wasted from all the hotels, and then trying to spread it around. But they are working in silo. So there are many organizations, they are not able to share all their data and all. If we can come up with a unified infrastructure to help all these organizations, I think that will also, ICICLE will create a big impact here. And if we'll be very happy to interact with people who are working in these areas, and then trying to understand their real-time needs, the data needs, and how they're handling, where they are the bottlenecks, and then whether we can design an intelligent cyber infrastructure to solve those issues better.
If I can add to that, just referencing back to something that Patrick had said when he gave his opening remarks, he talked about knowledge graphs or knowledge networks, and making these open, and they bring together information from different sources, so that they are, particularly if available publicly, it could shed information on the problem that then somebody else might tackle. So it could be that by taking immediate action in knowledge representation that we are doing through knowledge graphs, that we can help at least expose more information about the problem that can be tackled by someone else.
And if I can jump in as well, thanks, Beth. And that's this type of question is exactly where we're going with the Smart Food Sheds working group. And this specific question has come up multiple times, and we're definitely going to be pushing forward on questions very similar to that, using the knowledge graphs, like Beth said, to identify the actors and various products and processes and link them together in ways that are both efficient and effective.
Thanks, all of you there, for those answers. That's great. My question for you, and let's start back with you, Patrick. What would you say to the food systems actors who say, look, I don't want to share my data. My data is private, and I make business decisions off of my data, especially if I'm a distributor or someone who if I share my data, I lose my business model. How does transparency work with folks like that, and how do we move forward and engage folks like that?
Yeah, those are certainly big questions, and there's going to be all sorts of different kinds of privacy models that we're developing with all sorts of different actors as we move forward here in the next 5 years, working with Beth's group to develop some of those. And I would say that there's going to be some data streams that are private, and they can pull in the public part of ICICLE to work with that. There's probably going to be opportunities to aggregate across a region in ways that leave their particular data anonymous. There's going to be all sorts of different kinds of structures, and we'll be working through that over the next 5 years.
So Beth, then if I could just sort of hone in on that in your area, it seems like for this democratization piece, there's a real rub between data sovereignty and data transparency. And do you have a sense of that? Like, have you faced that in other fields in your time at NSF? How does that work? What's the rub there?
Yeah, and thank you for that. And yes, indeed, I did. I worked in the area of open science when I was at the National Science Foundation, and a national, a federal funding agency that grants funding to carry out research has a reasonable expectation to see the results of that research released to the public. So if one is funded through a federal agency, there's a data management plan and an expectation that one is making their data results as well as their software available for public use, or at least more restricted public use, respecting the fact that certain data cannot be pushed completely into the public domain. When there's proprietary issues involved, those need to be respected. There are ways to respect that while still being aware of the existence of the data. One could, knowledge graphs are great at pointing to the data, but not necessarily sucking all the data in. There are ways of anonymizing the data. This is usually negotiated through a data use agreement that the project would engage in with this particular partner, trucking company or something like that, to say, look, we will utilize synthetic version of this. It will create a synthetic version of this data, and we'll use it in our research, and then we'll use a part of it under these constraints. It'll be privacy protected, but those need to be worked out. So those, the constraints around data, whether they're human or protected by proprietary or for profit means or whatever, those need to be respected. And there are means today, particularly, again, I'm a big fan of the whole knowledge graph model. There are ways in which to benefit from data without necessarily saying, yes, you have to give it to us, we have to own it. Though that's one solution amongst a spectrum of solutions.
That's great. DK, you have any thoughts here about this sort of data sovereignty versus data transparency from what you've done in the past and your work with supercomputer facilities? How have you handled it, and the software you've developed for HPCs, high performance computing?
Yeah. Yes, Matt, as you said, we have developed a lot of software which are very widely being used. Of course, there the model is a little bit different. Like we have everything in an open source manner, but at the same time, there are a lot of companies, competitors, and all use those software also, and that is a little bit different model than what we are talking. But we have like a track record of working with 20 years for all different end users, like HPC users, HPC centers, national labs, as well as all these companies, big companies which are producing the hardware. So because everybody is a stakeholder there, so we are able to, through our software releases and all, we are able to bring everybody together there, that a common ecosystem can actually benefit all of them. So we can take a very similar model, but it will be a little bit different, as Beth and Patrick indicated. But we have put together a very nice deep learning infrastructure with security, privacy. You heard some of those things. So we are very confident that we'll be able to achieve that.
Courtney, you're muted.
Thank you, DK. I mean, we look forward to learning how these relationships progress, and even if ICICLE can help kind of standardize some way for, especially on the data side, but ways to interact a lot more efficiently without having to recreate these agreements every time. So thank you all for a really exciting conversation. Learned so much. Fortunately, we're about out of time here. And so it's time to close up. To our virtual audience, please join me in thanking DK, Patrick, and Beth for sharing their fascinating work on ICICLE. And we look forward to future conversations and collaborations in the months and years ahead.
Yeah, this is great. Before we close, we want to invite everyone to join us again next month in January 2022, so next year. When we explore new developments in sensory science, that is taste, smell, touch, sight, and sounds of food and the whole food experience. What does it mean to actually record data of a food experience? So that is something I'm very much looking forward to. And I just wanted to sort of maybe wrap up with one take-home message from this group that just keeps coming back to me. And that it seems to me that by building out a greater environment, a landscape for AI, we are enabling more economic opportunities for different kinds of actors. So increasing the number and diversity of actors who can participate in AI landscape. And I'm seeing you nodding yes, and that makes me really happy. So I just wanted to say that, and this next episode around taste, smell, and texture of food should be pretty exciting too.
Yeah, that will be exciting and really appropriate to be thinking about how food tastes coming out of the holiday season, right? So and don't forget, everyone. All of the previous New Food episodes are available on YouTube, so you can watch them whenever you like. And if you like what we're doing, please hit like and subscribe, and you'll be set up to catch all of our future episodes. And yeah, please just enjoy some great food over the coming holidays. We look forward to seeing you next time and next year. Bye, everybody.
Bye-bye.
Thank you. Bye.